All right, here we go. We've got a triangle. It's triangle ABC. We just talked about finding the angle bisector, so we know how to do that with one angle. But how many angles are in this triangle? There's three of them, right? So let's find the angle bisector of all three angles. Let's start down here at angle B. So I'm going to go right to the vertex, and I want to make this so that it divides that angle into two equal angles. So tell me when. See, I'm looking here, aren't I? I'm looking down here to see. Now, would that be it? No. Would that be it? No. It would be around about there. Again, I'm not looking to find the midpoint of the opposite side, am I? I'm looking at this angle. I'm looking at this angle right here, and I'm saying that, okay, that angle is equal to that angle. Got it? Again, I don't really have a nice way to figure out that. We just have to look at it and just kind of guess. All right. Now, if I had a protractor, an online protractor, I could stick it on here and figure out what the angle was, take half of it. But I don't have that, so we'll just eyeball it. Let's do it to another angle. Let's go up to angle A. All right. So help me. Oops, daisy. Let's go about right there. All right. So again, I'm not necessarily looking down here at BC to find the midpoint. What am I doing? I'm looking up at this angle A, right? I'm trying to split that angle A in two equal angles. So tell me where you think that would be. About right there? Okay. All right, right there. Okay, so what does that mean? That means that this angle is equal to this angle. See what we're doing? We're finding the angle bisector of all three angles. Now, guess what? In the first triangle, the perpendicular bisectors, all three lines intersected at the same point. So what would your guess be on this one? It's going to do exactly the same thing, okay? So if I started here, if I find the angle bisector, oops, I didn't give myself enough room. Let's try this again. Try it way out here, okay. All right, and if I found the angle bisector, it should, if I did it right, it should intersect those other two lines. Does it look like it bisects that angle? Yeah, it absolutely does, doesn't it? All right, so those two are going to equal each other. And guess what? It's kind of cool that they actually intersect at the same point. All right, if you don't believe me, you can get a protractor and you can try it yourself, split the angles in half, right, and you'll see that that works as well. Now, this is not called the circumcenter because the circumcenter is the point that we found by the perpendicular bisectors. So we give this another name, and we call this the incenter. We call it the incenter. Now, these words don't really, I don't know, to me, they don't really describe very well what's going on here. So it's kind of difficult to know which one goes with what. It's just a basic straight memorization, all right? You look at it and you say, okay, the perpendicular bisectors were the circumcenter. The angle bisectors were the what? The incenter, okay? You just have to remember that. That's all you got to do. Now, there's four of them that we're eventually going to do. We're only going to do two today, but we'll do two on Monday. But remember, find the incenter. How did we find the incenter? What did we do here? Okay, so we found the what? The angle bisectors, right. That's a lot easier to say, isn't it? The angle bisectors of what? Not each side this time, but what? Of each angle. Okay, so to find the incenter, which would be this point right here, we'll call it point P again. Point P is the incenter. Everybody got it? The three lines are not the incenter. The actual point P right there, is called the incenter. How did we find it? Found the angle bisector of all three angles, okay? Now watch this. Do you remember on that circumcenter? It was only like 5 minutes ago. But do you remember on the circumcenter it was equidistant from all three vertices? That's not going to be true here, all right? Because look at that distance right there from B to P. Does that look the same distance from P to C? No, it doesn't. So those distances are not the same. But there is a distance that's the same. So watch what I'm going to do. This is a little bit more confusing, but watch. The distance from this incenter to side BC is going to be the same as this incenter to this side and this incenter to this side. How do we find the distance from a point to a line segment? Do we go to here? Do we go to here? Here, here, here? Parallel? That's the distance from P to BC? That's parallel. Is that really what you wanted to say?
No.
That's parallel. That's parallel to BC. Right. It's perpendicular, not parallel. Okay, I know you meant perpendicular, right? But you said parallel, so that's what I went with. All right, so it's perpendicular. So watch, where would the perpendicular line be? It'd be right there. Now that was right because I hit the shift button, which makes it vertical. Okay. Now I got to eyeball the other ones, but that's okay. Watch. Where do you think perpendicular? Do you think it's right there? Maybe go about right there. That looks a little bit more perpendicular, don't you think? Okay. So there we go. And then what do we do here? We go to the over here. We go perpendicular. Where's about right in there somewhere? Okay. And that's perpendicular. Now look at these three blue lines. What do you think's true about those three blue lines? They're all the same length. That's right. So watch. The distance from this point to each of the sides, right? Because how do we define the distance from a point to a side? It's the perpendicular distance. So from this point to this side is exactly the same on all three of these. So let's call this, I don't know, X, Y, Z. Those 3 points right there. So what must be true then? XP must equal what?
XP is equal PY.
Right? Yeah, let's just go like this. YP and what? ZP. Everybody see that? So all three of those blue lines have to equal each other. Now again, that might look a little shorter than this one, but if I would have done this right, if I would have been real careful, used a protractor, and found the actual angle bisector, then this would look a little bit more accurate, but it's not too bad. For us, it's fine. Okay, so that all three of those blue segments are equal to each other. So what do you think they're going to do in the book? They'll probably give you the length of XP. They'll say it's 7. And they'll say, okay, what's the length of PZ? What would that be? It would be 7. Okay, they could do this. They could say, let's say that angle right there is 25 degrees. What would this angle right here be equal to? It's got to be 25. Why? Because it's bisected, right? It's bisected. These two are equal. Everybody see that? They may not tell you that this angle, watch this. They may not say that that angle and that angle are equal to each other. But they may tell you that this is the incenter. If they tell you this is the incenter, what must be true about these angles? They got to be equal. Why? Because we bisected it to get the incenter. Everybody see that? In fact, I can specifically remember on the test because my the honors class just finished the test on this chapter, and a kid came up to me and said, "Oh, I don't know what this angle is. There's not enough information." And I'm thinking, and the only hint I could tell him is that this point is the incenter. You got to know how to find the incenter. How do you find the incenter? You bisect this angle. So if this is 25 degrees, then guess what? That has to be 25 degrees. Make sense? Okay. And again, if I told you this length, I think one of the questions, I'm telling you right now, this is section 5.1. It'll be a while before you take the test. But I'll tell you right now, there's a problem that says this. It says, tell what other segments XP is equal to. So XP is equal to what other segments? Right? I've already written it down right here. But what do? XP's got to equal what? YP and ZP. You follow me? So that could very well be a question on the test. Everybody with me on that? All right. So that's the kind of stuff that they could ask you on there. So there you go. Now, that worksheet that I gave you yesterday, there was 2 sides to it. You should be able to do all of it now. We've covered everything. All right. So the rest. So I only had you do 1 through 3 on both sides. Yeah, that's right. Because did you notice on 1 through 6 we hadn't talked about that yet?
Yeah. No.
Yeah. So.
Oh, I just did it.
Yeah, you could kind of look at it and see anyway. You're absolutely right. Oh, you know what? I forgot one little thing. Hang on just a second. All right, I almost forgot this. This is called the angle bisector theorem. Let me just show you this real quick. Now, it's kind of self-explanatory, to tell you the truth, but I'll do it anyway. Let's find the angle bisector again. So where do you... Help me out. Does that look about like we're bisecting the angle, about right in there? Now watch this. Can you please? If I had a point on that angle bisector, okay, and I found... the distance from that point to this line. What would the distance from that point to this line be? How would I draw it? How would I draw the distance? I'd draw it perpendicular, wouldn't I? Okay? So if I drew that perpendicular, there we go. Now watch this. What if I found the distance from this point to this line? I'd have to go perpendicular as well, wouldn't I? Okay? What do you think might be true about those 2 line segments? They're going to equal each other. Exactly right. So if I'm told that these 2 angles are equal to each other, right, any point on this angle bisector is equidistant from the sides. again, it's kind of self-explanatory, I think. So, right, if I go to the distance from here to here and the distance from here to here, those both are going to be exactly the same. Got it? What if I told you this? Now remember, on this one, I told you that the angles were that angle was bisected. Everybody still with me? Pay attention now. Here's another version. Remember we talked about the converse yesterday? We took the if and the then and we switch it. So the first part said if the angles are equal, write that down. Watch. If the two angles are equal, right? You know what I'm talking about? If this one and this one are equal to each other, then the lengths or the distance from the point to the sides are going to be the same, right? I'll just really shorten it up. So the distances are equal, we'll say. Does that make sense? If these two angles are equal, then these two distances are equal. Got it? If we switch it around, what would it say? If what? Right. If the distance are equal to each other, meaning if I was told that these two are equal to each other, then guess what? These two angles are equal. Does that make sense? I really shortened it up a little bit, but you get the idea. So here's the deal. If I told you, and this was in the problems that you did last night, if I told you that this was 5 and this was 5 and this angle was 21 degrees, then what could you tell me? This angle right here is 21 degrees. Does that make sense? Okay, now you have a reason for it. Again, you could have just looked at it yesterday when you did it and say, well, that sure looks like it's half of it, right? So if that's 21, that's 21. Would you agree? But now you got a reason to back it up, though, okay? And what do we call it? We call it the angle bisector theorem, right? We call it the angle bisector theorem. Got it? So this is the theorem itself. This would be the what of the theorem. Remember when we switched the if and the then, what do we call it? Converse, right? This would be the converse of the theorem. Got it? Okay, it's kind of like a reciprocal, yeah. That's a good way to think of it. All right, make sense? All right, so now you're good to go. You should be able to do everything else on that worksheet, and that's all I'm going to give you. Just finish up that worksheet, and then I'll go over everything on Monday. Okay? So I'm not going to go over any of that stuff from last night right now. I'll let you use the rest of the time to work on this and try to finish up that worksheet. Okay, that's it. Have a good weekend.